Alright, so in this video we'll look at binomial expansions that involve using partial fractions. You might be surprised, what do these two different concepts have to do with each other at all? So let's look at this example and you'll find out. We've been asked to find expansion of this bracket being 4 minus 5x on the top of the fraction over 1 plus x multiplied by 2 minus x, including up to x to the power of 3. So, up to and including x to the power of 3. So, how can we use binomial expansion? How can it work? Well, let's first of all try to write it as partial fractions. Some factor over 1 plus x plus another factor over 2 minus x, or rather a constant. So we can rewrite this as a constant over 1 plus x plus a constant over 2 minus x. So how did we do binomial? How did we do partial fractions? We would of course multiplied a by 2 minus x and b by 1 plus x. We would have pretended that we are adding these two fractions on the right side and match the numerators with the numerators. Okay, so basically all you have to do now is solve this equation for values of a and b. Now you can use elimination. I would have used x equals to 2 to figure out value of b. So substituting x equal to 2 on both sides, we'll get that because that would eliminate this bracket here. So 2 here plus 1 gives you 3. Solving for value of b, you get b is minus 2. Then to eliminate the other bracket, what value of x would you use? I would use x equals to minus 1. So let's substitute that into both sides and you get a equals to 3. Now we rewrite these two values of a and b on the fractions and you'll see why this turns into binomial expansion. We've been looking at writing these such fractions all along as binomial expansion. So we're going to write each of these fractions separately and then maybe we can combine them together once the binomial expansion is done. So we can rewrite the first fraction like so and the second fraction like so. We will deal with them, each part of it separately. First, let's deal with 3 times 1 plus x to the power of minus 1, and then we'll deal with the other term after. So, we said we're gonna deal with this expansion. Luckily, we have a plus 1 next to the x inside the bracket, so we can just throw it into the formula, n being equal to minus 1 and x is x. We don't have to change anything for a coefficient of x, and you, after going through the motions, you end up with these terms need to be multiplied by 3, of course. So in the end, we'll get 3 minus 3x plus 3x squared minus 3x cubed. I've put that box on top of the right side of the page. Now we're going to deal with the second term. I know it has a negative in front of the 2, but the negative sign we'll deal with later. Let's just factor a 2 out of the bracket. So inside the bracket, we are factorizing a 2 to make this to a 1. Alright, that means dividing x by 2 as well. We'll make sure that this 2 inside the bracket gets a power of minus 1. So in fact, the 2 outside the bracket here, these two will cancel each other out anyway. Alright, so now we can throw the formula and use the formula here. We will have n equal to negative 1 and x being minus half x. We need to substitute minus half x into the formula, and we'll get terms. After going through the motions, you'll end up with this bracket here. Now, as we said, the 2's cancelled away. However, we do have a minus sign that we need to put back and subtract them from each other. So what we'll have is this expression here coming from the expansion of the first term, subtracting that, and subtracting the second box here from the bottom of the page. So 3 minus 1 minus 3x minus a half x, and so on. So you end up with this answer here. 3 and minus 1 will give you 2, and these terms will have to match up because power of x is matched, and you'll match the powers of x with the coefficients, and you'll get such answer. Alright, I hope you found this helpful. I'll see you in the next section of the course.